Welcome to our channel. In this tutorial, we will be diving into the fascinating world of augmented reality, AR, as we build a plant identification app using Java. If you're passionate about plants and technology, this is the right place for you. Before we jump into coding, let's understand what our app will do. The app will utilize AR to help users identify plants simply by pointing their camera at them. We'll integrate with a plant identification API that will return the plant's details based on its image. First, let's set up our development environment. For this project, you will need Android Studio installed on your machine. Don't worry, it's completely free and supports Java development. Make sure you also have the Android SDK installed. Once you have everything installed, create a new Android project in Android Studio with an empty activity template. Name your project AR Plant Identifier. Ensure that you set the minimum SDK to at least API level 24 for AR camera support. Now, let's add the necessary dependencies to our project. Open your build.gradle module file and add the following dependencies for AR Core and Retrofit, a type-safe HTTP client. Synchronize the project to ensure all dependencies are downloaded. This can usually be done by clicking the Sync Now button that appears in the top right of Android Studio after making changes to the build.gradle file. Next, we need to set up our AR fragment. In Android, AR Core works with an AR fragment. This fragment provides all the necessary tools to work with augmented reality. Open your layout file and add an AR fragment to it. Now, let's move to the Java file associated with our activity. We'll need to define an AR session and set it up. To do this, we'll retrieve the AR fragment and set a tap listener that triggers when users tap the screen. In the above code, we are setting up an on-tap AR plane listener for our AR fragment, which will allow us to place AR objects when the user taps on a detected plane. Next, we need to add functionality for capturing images of plants. For that, we will use an intent to open the device's camera. This will allow a user to take a picture of the plant they want to identify. Here, request_image capture is a constant that you should define in your class, like so. Private static final int request equals 1. This allows you to identify which activity result is coming back from the camera when you override the onActivityResult method. Once you've captured the image, the next step is to process it and send it to a plant identification API. We'll use Retrofit to handle the API requests. First, create a model class that represents the response from the plant identification API. Next, create an interface for our Retrofit service that defines how our app will interact with the plant identification API. It typically includes a method that sends a request with the image data. Let's move on to configuring Retrofit in your application. This will initiate the Retrofit instance with the base URL of the API and the converter factory, in our case, for JSON. Now, when the user captures an image, we will convert that image into a suitable format and send it to the API for identification. We'll convert the bitmap to a file and then create a multi-part body, part from that file. After preparing the file, we can then send this as a request to the plant identification API and handle its response. This is done asynchronously to avoid blocking the UI thread. Let's now process the response we get back from the API. Typically, the response will include information like the common name, scientific name, and an image of the plant. You'll want to display this information in a way that's friendly and informative. Create a simple layout for the results screen with text views for the name and the scientific classification of the plant. In the place where we process the API response, fill in the text views with the data received. You can use FindViewById to get references to your text views and set the text accordingly. Now that we've handled plant identification and UI updates, let's also add error handling to gracefully manage cases when users take a picture that the API can't identify. Finally, it's important to test our application thoroughly. You can run your app on an Android device with camera support and AR capabilities to test the plant identification feature. Ensure to test in various lighting conditions and against different types of plants to see how well the API works. This will not only give you confidence in your app, but also enhance its usability for others. To wrap things up, let's summarize what we accomplished today. We built an AR plant identification app that allows users to identify plants using their camera. We set up an AR fragment, used Retrofit to connect to an external API, and displayed the results to the user. If you enjoyed this tutorial, please give us a thumbs up and consider subscribing. We have more content coming your way on Java programming and mobile application development. Thank you for watching, and happy coding! We would love to see your implementations, so feel free to share your projects with us in the comments or on our social media channels.